When you're using inheritance, automatically the child class inherits all the methods that the parent class or the superclass has. Now, what if your parent class has a method and you don't like the way that method is implemented, and you as a child want to implement it in a different way? So you can do that, and this is called method overriding. So one of the common methods that we might want to override is the toString method. When we implement the toString method in our class, we are actually overriding this method in a parent class, and we'll learn about that parent class in another lecture slide. But for now, when I wanted to override the toString method, what I did was I wrote my own toString method, like public string toString, and I wrote my implementation. So let's say the person class, whoever implemented the parent class person, had this implementation. You know, they have the name, social security number, address, emergency contact, whatever the class contained. Now the child class student wants to implement its own toString method. It doesn't want to only print those 4 pieces of information. It wants to print extra pieces of information like the banner ID or GPA or a list of classes, whatever is being stored in student. So you can do that. So a child class can override a parent class method. It is very highly recommended that you add the @override keyword before your method declaration. So let's see an example of that, how it's going to work. So here in the person class, it has a message. It has a method called, let's have get display message return person's display message. So let's say the get display message, it's returning something that has something specific to the person class. Now, the student, let's go, and the get display message is in the empty student constructor. So let's call the empty student constructor. Okay. Here when I call student s equal to new student, it's going to call that method, the get display method, display message method, and it's going to say person's display message welcome, there's there in student. Okay, so it's having this method, this string being printed, and maybe, you know, student doesn't want this. Student wants to implement their own method. So what we can do is we can go and we, you know, copy this method. That's the one we want to override. We want to change the behavior, and we're going to paste it here, and we are going to, here we need to get display message get. And I don't want it to say persons, I want to say students. So I'm just going to say students. Okay. And so since I wrote the method myself, it's going to run. Oops, something's not right. What happened? Oh, I have an infinite loop because I'm calling myself. Okay, so let's just say this is what I'm going to print. Okay. So now the student constructor that we wrote, so let's just see what's going on. The student constructor that we wrote is going to go call the empty student constructor, and then it's going to call the get display message. Now, because the get display message is implemented in the same class, it's going to call that one, and it's going to return student's display message. Okay. Now, you see here, I didn't add the @override. If I did add it, it's going to still behave the same. Okay. So adding it or not adding it didn't really change anything. It's still doing the same thing. It's displaying student's message from here. Now, when is this useful? I'm going to show you when this is useful. So I'm going to take it out for a second. And now what I'm going to do is I'm going to so let's say the person, the get display message here gets changed. Instead of MSG, it's ME. Okay, so they change it to get display message like that. And here, this method, they told them, oh, you're calling us, we changed our name, so you need to change the name of your method. And they don't realize that they were actually overriding the method, okay? Now, here, the change that happened in person affected student. So now when I call this new code, the new method is being called on the person, the student is calling person, and this method that we were overriding didn't get touched. It didn't get touched by the code that was run, and no one realized it. So if I had written, instead, I had the override here, it will not, this code will not compile. It will tell me method does not override or implement a method from a super type. So let's undo a couple things just to show you. Let's go to the person and undo that one too. Okay. So here, the right way to do things is to come here and say @override to indicate that you are overriding a method that's implemented in your parent class. So everyone knows that this method is implemented in your parent class and you want to change the behavior. Now, if the parent class comes here and decides to change the method for some reason, okay, the code will not compile. So immediately your code here will stop compiling and it will say method does not override or implement a method from a supertype. It's telling you that you are trying to override a method that your parent no longer implements or doesn't implement. So this is a safeguard for you so that if your parent class changes its signature for some reason, it changes the method name, okay, or it changes the return type. You know, for example, it makes it void and it's not returning anything. In that case, you will know that that the method changed. So this is just a safe way of a way to make sure your code is safe and that it'll always work. So here it's telling me that it's not overriding it because the type is different. The other one is returning void and this one is returning string. So if you want to change the behavior of a method that your parent wrote, you can do that. There's no problem with it. The only thing that you should do just to make sure that you safeguard yourself is add the @override. It is not mandatory. Your code will work if you don't write the @override, but this is a way for you to make sure that if your parent makes any change, you will be notified. Your code will not compile, so you will know that they broke your code somehow. Now, the toString method is a method that you should always override. So let's say here, public string toString, and let's say the string class is going to print the name and for security reasons, we're not going to print the social security number. Is there anything else? That's it. Okay, so let's say we're only going to display name and return str. Okay. Now, as a student, I want to return the name in addition to more things. So I'm going to come here and I'm going to start writing my toString, and I'm going to add the @override public string toString. I'm indicating that I'm overriding the method. And I want to add the name, and I want to add the information stored in me, like banner ID, for example. Now, the right way is not to print everything. Remember when we were talking about aggregation, we said every class is responsible for recording and maintaining its own data. So here I shouldn't say name and then start calling the getName method and all that and call all the methods in person to get the data. Nope, that's not what I should do. I should go to the person class and say, get me the stuff that you want to print. So the way we refer to our parent, like we said, is using the word super. So super is the keyword that we use to refer to our parent. So here, when I wanted to refer to my parent constructor, I just said super because that's kind of being replaced with the word person, because the constructor name is just the name of the parent, like person. Here, I want to call a method on my parent. So I'm going to say super dot, and the method that I want to call on my parent is toString. Okay, so that's the first thing I want to print. And then in addition, I want to print extra stuff like my banner ID, for example, plus banner ID. append this string. And then at the end, I'm going to say return str. So just like aggregation, every class should be responsible for implementing its toString method. The same way with the equals method. If I wanted to implement the equals method, I would also use my super to make sure that super is equal. And if my super is equal, then I'm going to compare my stuff. Let's actually do that for practice. So let's see. Public Boolean equals. And here, let's take another person. And if name dot equals ignore case p dot get name, then I'm going to say return true. We're just going to assume that this is the only thing that I need to compare, otherwise return false. And so now I'm going to go to student and I want to override that. So I'm going to set at override public Boolean equals. And here I'm taking a student as an object. The first thing is I want to check my parent. Now here it doesn't like it because this is student instead of person. So we can just say person. So here this is, we're going to talk more about this later. So for now, I'm just going to leave it as student, but I'm not going to put the at override. It's still going to work like you know, because it's going to go and call, going to find the appropriate equals. But here what I'm going to do is I want to call my super first. So I'm going to say if super dot equals s and my banner ID is equal to s dot banner ID, then I'm going to return true, otherwise return false. So I'm equal if my parent says I'm equal and I have the same banner ID as them. And so in that case, I can get the equals also to work. Okay. So this is how you can override your parents' methods if you don't like them. Now, just like you have the ability as a child class to override a parent method, a parent can also prevent you from overriding a method. So a parent can write a method and say, if you're going to inherit from me, if you're going to extend me, you cannot override this method. And so the parent can put the word final, and the word final means that the child cannot override this method. So here in person, if the display method message method is one that your parent doesn't want you to override, they can put the word final. Remember, the word final was used to create constants. Like when we wanted to create pi, we would say final float pi equal to 3.14. So final was used to create constants that are not modifiable. Here also, final is can be used to create methods that cannot be overwritten. So now, if I save this and I go back to my student class and I look at the get display method that I tried overriding, it doesn't let me. It says that it cannot be overwritten, okay, because they made it final. So I can't do that. I have to just live with my parents' implementation. So parent classes have the option of preventing children classes from changing their methods using the word final. And children classes have the ability to change their parents' behavior by overriding the methods. So both are giving the flexibility to parents and the flexibility to children. And so in this classwork, you will practice the concepts that we learned in this lecture regarding inheritance. So you're going to implement a person class and save the data that I'm asking you to save, the name, address, phone number, all strings, create the constructors, create the accessor methods, and do what it's asking. You're going to create a customer class, and then you're going to write a main method that's going to be testing your code. Once you get it working on in NetBeans, you can test it on HackerRank, and don't forget to submit a screenshot of passing your code on HackerRank in addition to your Java code, your 2 classes.